Friends, now today we will discuss about refraction of light. We have already discussed about reflection of light. Now there is another term which is refraction of light. Okay, so you can see here for a refraction of light there should be at least two medium. At least two medium. It means that it may be air, glass, water, like that. At least there should be two medium. More than two medium can be possible also, but for refraction of light there should be any two medium. You can see in this picture there is two medium also. Number one medium, which is air. You can say this medium is air and this medium is glass, and this medium is also here in this picture we can see there are two mediums, air and glass. Okay, when a light ray passes through one medium to another medium, when a light ray passes through one medium to another medium, then it bends from its path. You can see here that at first light is moving in air medium, okay, and after point A it is moving in glass medium. So when light ray moves from one medium to another medium, then it bends from its path. That is called a refraction of light, okay, or we can say bending of light. This is a term refraction. You can say bending, okay, when a light ray travels from one medium to another medium, that is called refraction of light. And you can see here in this diagram also light ray in air, and after incident at point A it refracts in another medium. It changes its direction through AB, and when it strikes at B, then there is a change in medium, then it travels along a different path or it bends. So this phenomena is called refraction of light. Okay, now another term which is very important, there are two type of medium. Okay, one medium is usually called rarer medium, and another one is called denser medium. Okay, one is called rarer medium and another is called denser medium. You should know this thing. Okay, so we will discuss about this medium in upcoming videos or upcoming lines. Okay, at first you can see here this air, this is supposed to be rarer medium, and this is glass, this is supposed to be denser medium. Okay, this is a rarer medium and this is denser medium. Then this is another medium, air, this is rarer. Okay, when light ray travel from rarer medium to denser medium, okay, when a light rays travel from rarer medium to denser medium, then it, we can see in this diagram, it deflect from its path. So what type of deflection it should be, let's discuss this one now. Okay, okay, from this diagram you will understand this one very easily. This is a glass slab and this is air medium. Okay, this is air medium and this is glass medium. Light ray, this is incident ray. Okay, this is point of incidence O, and this is a refracted ray. We can see here light is deviating when it moves from air to glass. Now uh, there is very important thing that there is a point of incidence and we should draw a normal from this point. Okay, we have drawn this normal at point of incidence, and we know about normal. This is the perpendicular line from that point O, and this is incident ray, this is refracted ray, and these angles, this angle is angle of incidence and this angle is angle of refraction. What is angle of incidence? Angle of incidence, the angle between incident ray and normal, that is called incident angle. And what is angle of refraction? The angle between refracted ray and normal, that is called refracted angle or angle of refraction. Okay, and about normal, we have drawn a perpendicular line from the point of incidence, which is O. Okay, that perpendicular line is called normal. Okay, now you can see here I was discussing about that thing, that this medium is rarer medium, okay, and this medium is denser medium. Okay, this is denser medium. Okay, whenever light travels from rarer to denser medium, then it comes close to normal. It comes close to normal. You can see here, if there would be no glass, then light would be straight line like it now. Okay, but because of this glass medium or because of this denser medium, the light get refracted, or light refracted light ray move towards normal. Okay. So when a light ray moves from rarer medium to denser medium, dear students, then it comes close to normal. This is important point. Okay. In another case, if there is a light ray which move from denser to rarer medium, okay, which move from denser to rarer medium, then it move away from the normal. Then it move from away from the normal. You can see in this diagram. Okay. We will draw normal here, and we will draw normal here. You can see here, when light ray moves from rarer to denser medium, it comes close to normal. And when it moves denser to rarer medium, okay, it go apart from the normal. So this is the basic thing regarding the refraction of light. Okay. So one important question arises from here, that why it happen, okay, why light refract. So the answer of this question is very easy, and you should know the answer of this question, that when a light ray travels in another medium, so its speed of light also changes. Okay. When light travels from one medium to another medium, it changes its speed. Due to change in speed, it bends from its original path. As we know that the speed of light in air is air or vacuum, which is 3 into 10 to the power 8 meter per second. This is the speed of light in vacuum, we should say. Okay. This is the maximum speed of light. Okay. This is the speed of light in vacuum. But another medium, suppose if there is a glass, the speed of light in glass decreases, okay, in compared to this vacuum. So the difference in the speed of light in different medium, due to this thing, the light bends from its path, or we can say the light refracts. Okay. This is also very important thing which you should know. We can understand this from these two diagrams also, that when light moves from rarer medium to denser medium, then we can see here, okay, the light bends, and it bends towards the normal. And in this case, you can see the light is moving from glass to air. It means that denser medium to rarer medium, then it moves away from the normal. Okay. And we have one another definition for denser or rarer medium from here. You can say where the speed of light is maximum. Suppose we have two medium, air medium and a glass medium. Okay. The speed of light in air is more than glass. That's why we say air is a rarer medium and glass is a denser medium. Okay, got it my point? Suppose there are two medium, one air and second one is water. Okay. So tell me, where is the speed of light maximum, in air or in water? As we know, the speed of light is maximum in air in compared to water. Okay. So I should say the speed of light is more than in air in compared to water. So in these two mediums, we will say that air is a rarer medium and water is a denser medium. Okay. We can take another example. Suppose here is a glass and here is a diamond. Okay. This is glass and this is diamond. Suppose light is moving from glass to diamond, then which is rarer medium and which is denser medium? As I already told you, where the speed of light is lower in compared to other, that will be the rarer medium. So in this case, glass is a rarer and diamond is a denser medium, because the speed of light is more than denser. Sorry, the light of speed in glass is more than the speed in diamond. So that's why we say that the glass is a rarer medium and diamond is a denser medium. So it depends on the mediums, that one is called rarer and another is called denser medium. Got it? So you can see from here also, here is a parallel sided, this is a glass slab and this is a air. Okay. And the light is moving from air to glass. So from this diagram we can see that air is a rarer medium, because the speed of light in air is more than the denser medium, that is which is glass. This is important things. Now dear students, look at this diagram. Okay, this is very important diagram, and we will know the concept, some concept related to refraction also from this diagram. You can see here, this is a glass slab, and this is air, and this is also air. Okay, we do this activity in our lab also. This is air, this is glass, and this is also air. Okay, when light ray moves from air to glass, as we know, this is incident ray, this is normal, so this angle is called angle of incidence. Now from here, because this is rarer medium, this is denser medium, now we know that light will move towards the normal. Okay, so light will move like this one, this is refracted ray. Okay, so this angle is called angle of refraction, no problem in that. Okay, now this ray will strike at point B. Now from this point it will move to the air, means that it will move to rarer medium. So in this case we can see this is denser medium, this is rarer medium. When light moves from denser to rarer medium, then it will move apart from normal. Okay, this is the basic thing which we can draw easily. Now what to do? We have to do one thing here. Dear students, you can see here, this is incident ray and this is at last. Okay, or we can say this is emergent ray, which is moving through glass slab. Okay, it comes out from this point, so this is called emergent ray. This is incident ray. You can see here, this is the original path of incident ray. Okay, if there would not be glass slab, then light moves like this one. Okay, so we can say this is the original path of incident ray. This is the original path of incident ray. And what about this? But we put glass slab in the direction of incident ray, but the light ray emerge from here, so that's why it is called emergent ray. So this is the original incident ray and this is the emergent ray. So the distance between emergent ray and that direction of original ray is called lateral displacement. This thing you should also know, that the distance between emergent ray and the distance between emergent ray and the direction of original ray, that is called lateral displacement. And from activity we also know this thing, that the angle of incidence, this is angle of incidence, this is angle of refraction, and this is angle of emergence. Okay, the angle of incidence is equal to angle of emergent. This is very important point related to refraction of light. Angle of incident equal to angle of emergent. Okay, what is lateral displacement? Lateral displacement, this is the perpendicular distance between the emergent ray and the direction of original ray, that is called lateral displacement. And what is the important thing? When a light goes from a glass slab, when it moves from glass slab, we have seen that the angle between, or we can say the incident ray, is equal to the emergent ray. So this is very important thing, dear students. Okay, you will draw this in your copy also, and you will write the refracted light when it moves from glass slab. Okay, we can see we can say this thing. Okay, go through this video today, dear students. Thank you.